Algebra 2, this is Chapter 6, Section 7. This is the fourth video in the series. This one we're going to talk about the height of a ball above the ground after it's thrown upwards at 40 feet per second. And we can model it with this function given right here, 16 feet per second being the acceleration due to gravity, per second squared, sorry, and 40 feet being the initial velocity. Where the height h is given in feet and the time x in seconds, we're talking about feet per second. What time in its flight is the ball within 15 feet of the ground? So we want this height. We want to know when this height is going to be less than or equal to 15 feet, basically is what we're talking about. So we can take our equation, and we've got 40x minus 16x squared, and we want that to be less than or equal to 15. From there, we need to rearrange it so it's in the proper quadratic form. So it's going to be minus 16x squared plus 40x. Move the 15 to the other side, so we're going to subtract 15, and that's going to be less than or equal to 0. We always want to set it equal to 0 because we're trying to find where we are on our x-axis. From there, this looks kind of ugly, so I would use my quadratic formula and a calculator. So we need our quadratic formula. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. And go to YouTube and just Google of the quadratic formula song, and you'll see a bunch of those to help you sing that better and make you memorize this a little bit better. So x is going to be equal to negative b, but b is negative b. So b is 40, so it's negative 40 plus or minus the square root of b squared. So 40 squared, so that's 1600 minus 4 times negative 16 times c, which is negative 15, all over 2a, so that's negative 32, a being negative 16, right? So then grab your calculator, and let's go to town and figure. I'm just going to do my discriminant first. So x is going to be equal to negative 40 plus or minus 40, and I'm going to leave the negative 32 down here, and I'm going to get my decimal approximation here. So plug that into the calculator. That's going to be the square root, oops, second square root of 1600 minus 4 times negative 16 times negative 15, and I get 25-ish, 25.298, and we can worry about our decimals later. Okay, continuing with our calculator, let's plug that in. So I need this to be equal to negative 40 plus the 25.298 or whatever, all over negative 32, or I need the negative 40 minus the 25.298 or whatever, all over negative 32. So from there, I need to plug those both into calculator. So negative 40 plus 25 divided by negative 32, and I get approximately 0.46. So approximately 0.46. And then on the other one, it's going to be negative 40 minus the 25.298 divided by negative 32. And this one's going to be approximately 2.04. And then we've got to figure out what this is and what this is telling us. So our original question was, at what time in its flight is the ball within 15 feet of the ground? Okay, well, for the first 46 seconds, because this is going to be a parabola, let's just draw a really quick sketch of this thing. So we've got our x and y axis, right? And this is going to be parabola facing down, right? And we're crossing the x-axis at a half, basically, and 2, and then right here, and it's facing down, right? So here is when we're within 15 feet, right? There's going to be one other thing you're going to want to think about, though. Eventually this thing's going to hit the ground, and then the seconds aren't going to matter anymore. So you might want to figure out when this thing's going to hit the ground as well. This is when it's going to be within 15 feet. So the first 0.46 seconds of its flight, and then after 2.04 seconds until it hits the ground. And so to figure out approximately when it's going to hit the ground, you would take the original equation and have it equal to 0 instead of the 15 4 feet above the ground. It would be 0 feet above the ground. Rewrite it into the quadratic formula, the standard form. Fill it into your quadratic formula, and you get approximately 2.5 seconds until it hits the ground. And that would be the full answer, is all of this. So the first 4.6 seconds, and then from 2.4 seconds out to 2.5 seconds, it would be within 15 feet of the ground.